Students, today we are going to learn how to prove that any root 3, root 5, root 7 type of problem is a irrational numbers. Till that we know that if root m is any real numbers and if m is not a perfect square, then that root for m is a irrational numbers. It means that till that we have learned that root m means root m is not a perfect square. First point is this, and second point is that m is any real numbers. So what type of number is this? We have already know that if any number is in the form of this, then this number is a irrational numbers. We have already learned in class 9 that if any number is in the form of this, then that number is a irrational numbers. But now here we have to prove that root 3 or root 5 or root 7 is a irrational numbers today. How to prove that? So we will learn the here itself. So the topic will be revisiting the irrational numbers. So here it will be given that prove that root 3 is a irrational numbers. So we have to prove that root 3 is a irrational numbers. So we will take the proving this by the contradictions. We will assume that root 3 is a rational number. So what we will take on a contradictions, we will take contradictions means opposite. So we will assume that assume that root 3 is a rational number. What we are taking? We are taking here the opposite means contradictions. We are taking root 3 is a rational number. And what is the rational numbers? We all know that rational numbers are in the form of p by q, whereas q is not equal to 0, and p and q have no common factor other than 1. Means these p and q have no factors in common. So this p and q is so we will take root 3 is equal to p by q. So this is the step number 1. We have to assume that. Step number 2 says state that here root is there. We have to remove that root. So what we have to do? We have to square the both sides. So what we have to do? We have to remove the square root. So by how we are going to remove that? So we are going to remove that squaring both the sides. Squaring both the sides. So if we are going to square both the sides, so root 3 whole square is equal to p square by q square. If 2 times the same number is there, 3 will come out p square by q square. So if we are transposing this q square from right hand side to this side, what will be there? So from here what we are getting? We are getting the information that here from here we are getting the information that 3 is the factor of p square. It means that 3 divides p p square. So as per the theorem, we are dividing this 3 here and 3 here. It means that the p square is divided by 3. So we have written here 3 divides p square. It means that 3 is also divisible by so p. So if as per the theorem is that if this any number is dividing the p square, then 3 will also divide that particular number. So we are what we will take? We will take let p is equal to, in the term of 3, any integer. Let's see, we are taking any real number we are taking, sir. So p is in the form of 3, a multiple factor of 3. So p is equal to 3c we are taking. So what is the second equation? The third step. Third step is that let assume that p is equal to the 3c. You can see, take any of the alphabet, C, M, anything you can take, but 3 is there taking because 3 divides the p. So always in the terms of 3. If you are proving root 5, then 5 will come here. So it will be 5c. So as per the number itself, this value will go change. So we are the fourth step is that put the value of p as 3c in equations. So here we are writing 3q square is equal to 9c square. Q square is equal to 9c square by 3. Q square is equal to 3c square. So from here, what you are getting the information. You are getting the information. 3 is also information. What information you are getting? That 3 divides q square, so 3 can also divide q. So 3 can also, if you are dividing this 3 by 3, it means that if left and right hand side is divisible, then that number will be divisible by 3 also. So from here we are saying that this q is also, the 3 is also the factor of q, and here the 3 is also the factor of p also. So from here 3 and 3, we can say that from the assumption we have taken that p and q do not have the common factor. But what we are seeing that p and q have common factor, that is 3. So with our assumption, whatever the assumption we have taken, our assumption is wrong. So we will say that root 3 is a irrational number. Getting the points, my dear students? What you have to prove that? You have to prove that here p and q is not a common factor. What we have taken? We have taken in the first that p and q do not have any common term. Now we have established that after doing this, all the procedures, what we are trying to state that this p and q have the common factor, and that common number is 3. So we are the assumption whatever we have taken in the first, that root 3 is a rational number. Our assumption is wrong. So root 3 is a irrational number. Similarly, you have to prove in case of root 3, root 5 also, root 7 also, and rest of the numbers in your home also. So likewise only you will write. Now keep watching my videos. Thank you very much.